In this section, we're going to go over reflection. And as I stated before, if you remember the rules for absolute value and quadratic, it will be pretty much the same rules for cubic function. So let's do a little review from absolute value and quadratic. Now for example 7, we have two equations where g of x is written in absolute value form and h of x is written in quadratic form. So g of x is negative of absolute value of x, and h of x is negative x squared. Now I've written in two forms. The first one is without the parenthesis, and the second one is with parenthesis. And I stated before, sometimes some people find it helpful to write the parenthesis so that they can see that the negative sign is outside of parenthesis. So again, for reflection, you would know you have a reflection is if you have the negative sign. So for g of x and h of x, they have the negative sign that's outside the function. So if the negative sign is outside the absolute value or outside the parenthesis in the front, then it's going to be reflect across the x-axis. So again, because of these negative sign that's outside in front of x, then it's going to be reflected across the x-axis. Now moving on to example 8, we have n of x equals to the absolute value of negative x, and then p of x is the square of negative x. So in these two equations, n of x is written in absolute value form, and p of x is written in quadratic form. But if you take a closer look, they have the negative sign that's inside the function in front of x. For n of x, the negative sign is inside the absolute value line. For p of x, the negative sign is inside the outer parenthesis. So be prepared that if you have two set of parentheses, make sure you take a look at the outer parenthesis. But I'm just trying to illustrate that since we have a negative sign for reflection, and since it's inside the function, meaning inside the absolute value, inside the outer parenthesis, then most likely it will be reflected across the y-axis. So again, if you have the negative sign that's inside the absolute value or inside the outer parenthesis, reflect across the y-axis. So that means that the rules would apply the same for cubic function. So let's take a look at example 9. Example 9 is m of x equal negative cube of x plus 2. So the negative means that it's going to be a reflection. Since it's outside the outer parenthesis in the front, it's going to be reflected across the x-axis. Now, we also have this plus 2, meaning that it's going to translate left 2 units. So again, this negative sign that's outside the outer parenthesis in the front reflected across the x-axis. The plus 2 that's inside behind the x, again, just a review from translation, translate left 2 units. And again, to clarify, you will only know that it's a reflection if it has a negative sign in front of the function, in front of the outer parenthesis, or in front of the x when it's inside, which you would see in example 10. In example 10, w of x equals the cube of negative of x minus 5. So in this example, we have two sets of parentheses. And the reason we have two sets of parentheses is because for two reasons. The first reason is because we have the negative sign that's inside the outer parenthesis and in front of x. Since you need a second set of parentheses is because we have this minus 5 inside behind x. So we want to keep this negative sign separate from the minus 5, because if you distribute, it will be plus 5, and that's going to be confusing when it comes to translation. Now, to review, when you have a negative sign that's inside the outer parenthesis, it's going to be reflected across the y-axis. And then, since we want to keep the negative sign separate and keep the minus 5 intact, hence the reason why we have a second set of parentheses, the minus 5 behind and inside the function means translated right 5 units. So again, reflect it across the y-axis because of this negative sign that's inside the outer parenthesis, and then translate it right 5 units because of the minus 5 inside behind the x.